Very often in recommending systems, we are faced with a scenario where we are given ratings given by users for different objects, like say movies. And we have to understand how to use the ratings for potentially future recommendations for a new user, or potentially recommending a new movie to a user, or potentially recommending a, rating which extrapolating a rating potentially which can be given by a new user or an old user who has forgotten to give his rating, etc., etc. So what happens is the input to this become what is known as the user ratings to provide a feedback on different kinds of recommendations to be given to the end user or for rating, etc. In such cases, we use a technique called as matrix factorization, or more specifically called NMF, or non-negative matrix factorization. This is an interesting technique where what we try to do is we assume that the ratings given by a user is based on some hidden characteristic, or what we call as latent semantic characteristic of the objects, maybe the movies, which is making users, base themselves to give such a rating. So what our goal is, using some kind of a machine learning approach, which may be some technique like non-negative matrix factorization, to identify what are the characteristics which make users vote so to the corresponding movies. And such kind of an approach is done by viewing technically the ratings matrix. Let's assume here we're talking about 7 users, and for 6 movies, we see that there are 6 columns, 7 movies. We assume that, suppose there are 3 broad hidden characteristics of the movies, which is making the users use those characteristics to generate this or give this subliminal rating. Then what we break this into 2 parts. First one, we'll call them as the matrix representing how much each user likes specific characteristics of the movie. So let's name them. For example, you can say that 3 characteristics are: does it have a superstar like Amitabh Bachchan or Rajinikanth? Is it an animated movie? Or does it have fights in the movie? So there are 3 different characteristics of the movie, which is making them react based on the condition which they would give the ratings, which are being correspondingly manifested in the ratings chart. So U matrix, which is a 7 by 3 matrix, actually gives something like the potential for each user to like the corresponding characteristics. For example, you may say that I have a superstar, animation, or F. These are the 3 characteristics, right? So each of the user, I will have a matrix with 7 rows and 3 columns. I may like this 1.5 times, 2 times, 1 time, like that. So what happens is this represents the relative measure of how much of these characteristics which the individual user likes, times how much of that characteristic is present in each of the movie. So if you see here, we're talking about 3 characteristics, right? S, A, and F. Then we talk about movie 1, movie 2, movie 6. So we form a what we call as 3 by 6 matrix, which represents the question: how much of superstar characteristics is present in movie 1, movie 2, movie 5, so on and so. It could be 0.5, 0.7, 1, 0.9, something like that. But the key idea is you're trying to evolve an unknown entity known as latent semantic hidden characteristics of the movies, which is making users react the way they are and giving the ratings. So what we have done is we have taken the pain of giving some shape to these characteristics of the movie, which are not overtly present in the ratings, but internally they are the ones which are driving the corresponding behavior or the rating that is given. And this is a very common machine learning problem in recommendation systems, where given a ratings matrix, you try to discover the hidden characteristics. In this case, we're talking about 3 characteristics, it could be 4, 5, but usually it's not a very large number of characteristics you work on. And you decompose the original rating matrix into 2 matrices such that the product is the ratings matrix. So the machine learning problem becomes to find the combination of U and V such that the product gives you the corresponding ratings matrix. It will not be exact, but it will be somewhat approximate match the product with that. And that will give you the hidden metric corresponding to each movie which is responsible for users voting in that manner. So the machine learning problem here becomes the problem of matrix factorization, where you take ratings matrix, factorize it into 2 smaller matrices, one representing users to characteristics, another representing characteristics to the movies matrix. And this is a very powerful technique which is used for identifying hidden factors in large ratings matrices. Why is it useful? It is useful for, suppose there are some vacuums in this, some people have forgotten to give ratings. You can use this matrix to derive what the potential rating a user could have given for a specific movie. Or you can predict who are the ones which are users which are very similar in terms of ratings to what others have given. Or you can find out which is the movie which is very closely related to other movies. So all of this can be done by using the derived matrices which are being responsible for the target data that is given here. So you see that this is a very powerful technique for recommendation systems in order for extracting latent hidden semantic factors for corresponding ratings, which is a very important input for recommendation systems and a very useful category of unsupervised learning.